Let's compute the composition of f and g, so which is f of g of x. This means that our input of the function f is not x, but it is the function g of x, because the function f is equal to 2x minus 6. We have 2 times g of x minus 6. Then we have 2 times 1 over x plus 4 minus 6. So we get 2 over x plus 4 minus 6. Let's find the domain of this composite function. The first step is to find the domain of g of x. The domain of g is the domain of 1 over x plus 4. Because the denominator cannot be equal to 0, we have x plus 4 cannot be equal to 0. So let's set x plus 4 is equal to 0 and solve for x. We get x is equal to negative 4, which means that x cannot be equal to negative 4. So the domain of g is all real numbers except negative 4. The second step is to find the domain of f of g of x. F of g of x is 2 times g of x minus 6, or equivalently 2 over x plus 4 minus 6. In the equation of 2 over x plus 4 minus 6, the denominator x plus 4 cannot be equal to 0. Let's solve the equation of x plus 4 is equal to 0. We get x is equal to negative 4, which means that x cannot be equal to negative 4. So the domain is all real numbers except negative 4. The intersection of 1 and 2 gives us the domain of the composite function f and g, which is from the negative infinity to negative 4, union of 4 to infinity. Let's compute the composite function of f and g at x is equal to 0. We have 2 over 0 plus 4 minus 6, which is 2 over 4 minus 6. So we get 1 over 2 minus 6. Then we get 1 minus 12 over 2. So the answer is negative 11 over 2. Using the original function f and g, we get f of g of 0. G of 0 is equal to 1 over 0 plus 4, which is 1 over 4. Then we have f of 1 over 4, which is equal to 2 times 1 over 4 minus 6. Then we get negative 11 over 2. Let's compute g of f of x. Our input of g is f of x instead of x, so we get 1 over f of x plus 4. Then we get 1 over 2x minus 6 plus 4 is equal to 1 over 2x minus 2. Then we get 1 over 2 times x minus 1. Let's find the domain of this composite function. The first step is to find the domain of f. The domain of f is from negative infinity to infinity. The second step is to find the domain of g of f of x. The domain of g of f of x is the domain of 1 over f of x plus 4, or equivalently 1 over 2 times x minus 1. If we use the expression 1 over f of x plus 4 to find the domain of g of f of x, then the denominator f of x plus 4 cannot be equal to 0. So let's solve f of x plus 4 is equal to 0. Then we have 2 of x minus 6 plus 4 is equal to 0. 2x minus 2 is equal to 0. We get 2 times x minus 1 is equal to 0. And this is the condition we arrive if we start from the expression 1 over 2 times x minus 1, because the denominator 2 times x minus 1 cannot be equal to 0. So we get x minus 1 is equal to 0, x is equal to 1, which means that x cannot be equal to 1. So the domain is from negative infinity to 1, union of 1 to infinity. The intersection of 1 and 2 is the domain of the composite function of g and f. So we get from negative infinity to 1, union of 1 to infinity. Let's find f of g of x with the given f and g. We get g of x is equal to g of x minus 2. After computations, we get negative 3 over x squared minus 4. Let's find the domain of this composite function. The first step is to find the domain of g, which is the domain of 6 over x squared minus 1. Because x squared minus 1 cannot be equal to 0, we have x squared minus 1 is equal to 0, x squared is equal to 1, x is equal to plus minus 1, which means that x cannot be equal to plus or minus 1. So the domain is all real numbers except plus minus 1. The next step is to find the domain of f of g of x. It is the domain of g of x over g of x minus 2, or equivalently negative 3 over x squared minus 4. If we start from g of x over g of x minus 2 to find the domain, we get the following. Instead, let's start from negative 3 over x squared minus 4. Using the expression, the domain x squared minus 4 cannot be equal to 0. So we have x squared minus 4 is equal to 0, which is x squared is equal to 4. we get x is equal to plus minus 2, which means that x cannot be equal to plus minus 2. So the domain is all real numbers except plus minus 2. From the intersection of 1 and 2, we get the domain of composite function of f and z, which is all real numbers except plus minus 1 and plus minus 2. Given the function h, find two functions f and g such that h of x is equal to the f of g of x. The function h of x looks like an absolute value function taking 2x squared minus 5 as an input. Because the function g of x is an input of the function f of x, we can pick g of x is equal to 2x squared minus 5. And the function f is going to be the absolute value of x. If the function h of x is equal to cube root of 5x plus 1, if g of x is equal to 5x plus 1, the function f of x is the cube root of x.